So this is number 25 on the study guide. Number 25 says to plot the points and complete the coordinate proof. So the first thing we're going to do is we're going to plot these points. So we're supposed to do -3, 1. That's going to be called P. We're going to do 1, 3. That's called Q. We're going to do 5, 1. That's going to be R. And then we're going to do 1, -1. That's going to be S. And now what we're going to look at is we're going to try to figure out what kind of figure this is. If we were to connect these lines, and typically you'd use a straight edge, I'm just kind of shortcutting it, but connect your dots. And what I see is something that does not look like a rectangle or a square. And I can prove it by just showing you that the slopes are not opposite reciprocal to make perpendicular lines. This slope is up to over 1, 2, 3, 4. So this slope is positive 1/2. This slope is down to over 4, so that's going to be -1/2. Although those are opposite numbers, they're not reciprocals. One would have to be 1/2, 1 over 2, and the other would have to be 2 over 1. So it's definitely not a square or rectangle. But because these slopes match in the down to over 4, it is likely that this is now going to be a rhombus because since the slopes are the same, except that one is going positive and one is negative, it's likely that those lengths are the same. So that's what we're going to say, is that this is going to be a rhombus. But then if we're going to prove that it's a rhombus, basically we want to prove it by any which way you've learned through your class, but I'm going to go ahead and just do this today by starting with the fact that I'm going to prove first that it's a parallelogram. So if I prove that this is a parallelogram, my goal is to prove that the opposite sides are parallel. So that would be like PQ has a slope of, let's look, it's rise 2, run 4. And then let's look at my SR slope. And that one's going to be rise 2, run 4. So those two slopes are the same. Now let's do the other slope here. The other slopes would be like QR slope. So this time we're going down to over 4, so that makes it -2/4 or -1/2. And then we're going to do the PS slope. So if we look at PS, we're going down to over 4. It's that same slope, -2/4 or -1/2. So now I can say that PQRS is a parallelogram. So that's the first thing that allows me to prove it. The next thing is that now that I know it's a parallelogram, I just have to prove that two consecutive sides are congruent. In other words, I could prove that this side and this side were congruent, or this side maybe and this side. You just pick two. I'm going to pick PS here, and I'm going to go ahead and figure out how long it is. And I'm going to do that by Pythagorean theorem. So if I look here and I make a right triangle out of this, basically what I see is I have 2 units for this side and 4 units for that side. So Pythagorean theorem would mean to take my leg squared plus my leg squared equals my hypotenuse squared. Now my hypotenuse is PS here. So that would be 4 plus 16 equals C squared. So C squared would then equal 20. So when I take the square root of both sides, C would be the square root of 20. Now I could simplify that, but I'm actually going to leave it because now if you'll see, I'm going to go ahead and make the right triangle for this set of sides, the next side over. And that is 4 units, and that is 2 units. So again, for SR, what we're going to do is we're going to use Pythagorean theorem, leg squared plus leg squared equals C squared. And I already did this problem, so I already know that that's all going to be 20 equals C squared, and C is going to equal square root of 20. Do those match? Absolutely. So now that I've got 2 consecutive sides here that are exactly the same length, they're congruent, I can say PQRS is a rhombus, and I have now completed my coordinate proof.